Hi, in this video we shall solve this problem before us. This is a problem on the application of Coulomb's law of forces. This question will interest you and I bet you to keep watching to the end. At the end of this video, I shall put up a similar problem for you to solve and put the answer in the comment section. The question says, three charges Q1, 6 microcoulomb, Q2, minus 6 microcoulomb, and Q3, 4 microcoulomb are located at minus 0.6I, 0.6I, and plus 0.8J. Find the net force on Q3. Find the net force on Q3. Solution. According to Coulomb's law, he said that the force between two charges is proportional to the product of the charges and inversely proportional to the square of the distance between them. So Charles Coulomb is a French physicist. He found out that the force between two charges is proportional to the product of charges and inversely proportional to the square of the distance of separation. So we shall be making use of this to solve this problem. So if this is the first time you are watching this video, take time to go to our playlist to find other videos that might interest you. And if they interest you, you can subscribe for updates. So to find the net force, so the net force will be the force on Q3 due to what? The charge Q1 plus the force on Q3 due to the charge Q2. Because remember, we're asked to find the net force on Q3. So for us to do this, so let us draw this, draw a diagram to illustrate this. So if I have a cardinal point here, this is a cardinal point. Of course, in this case now, let me label it. Let's take this as XY plane. So this is y-axis, positive y. This is positive x. This is negative x. And this is a negative y. So we shall be using this xy plane, forming cardinal points, to represent what we have here. So the Q1 is located at minus 0.6I. So this is I is taken as x-axis. So we have minus 0.6I. And seated here is what? Q1. And what is the value of this Q1? So let me clean this so that it doesn't confuse us. Let me clean this axis. So what is this Q1? This Q1 is 6 microcoulomb. Then Q2, which is minus 6 microcoulomb, is located as positive x-axis. So we have 0.6I. Okay, and this is seated what? Q2. So Q2 is minus 6.0 microcoulomb. So the minus 6 microcoulomb. And the third one is Q3, which is seated at 0.8J. That is positive y. So we have 0.8 what? J. So the question says, of course, this is the Q3. This is 4 microcoulomb. 4 microcoulomb. So the question says, what is, or find the net force on Q3. This net force on Q3 is the force on this Q3 due to this charge. Due to this what? Charge. So this is the force on this Q3 due to what? This charge Q1. And we say that the net force will be the force on 3 due to 1 and the force on 3 due to 2. So this will be the force on this 3 due to the discharge placed at what? Q2. So we shall be making use of this to solve this problem before us. So we have something like this. Let's give other construction. So we have, this is 0.8J. This is Q3. This is 0.6I. This is Q2. And this is Q1. This is Q1. Q1 is giving us 6 microcoulomb. And this is minus 0.6I. This is 0.8J. So to find the distance between this charge Q3 and Q2, we have it as R32. And the distance between Q3 and Q1, we have it as R3 what? 1. So we can also define the unit vector in this direction. We have it as R3 hertz. And the unit vector in this direction is R3, 2 watts hertz. So we shall be making use of this now to go further to solve the problem before us. So to find this R31, okay, which is the magnitude of this, we have it as the magnitude of R3 minus what? R1. So, and similarly, to find the distance here, of course, this will be R32 will be R3 minus what? R2. So take note of this. We shall be making use of this to solve this problem before us. And to find this R3, that is the unit vector in this direction, we have R3, 1 hertz equals R3, this vector, minus R1 upon the magnitude. We have R3 minus what? R1. Similarly, we have for R32, we have it as, this is R3 minus R2 upon the magnitude, R3 minus what? R2. So we shall be making use of this to further solve the problem. So going further to solve the problem, we said before that the net force is F31 plus F32. So let us find F31. To find this F31, we make use of the Coulomb's law. This is the constant. This is the charge Q3. This is the charge Q1 upon the distance of separation. This will be 3, 1 square. We are following from the Coulomb's law. All right. So, and the unit vector in this direction will be given as this. And we have defined this already to be Q3, Q1 upon this R, 1 square will be R3 minus R1 square. And this unit vector in this direction will be, okay, this will be, so, and this will be R3, this vector minus, this is R1, then we have, this will be R3 minus what? R1. So this is the unit vector in this direction. Of course, remember that we've stated this earlier. So the unit vector in this direction is this, R31. So you have R3 minus R1 on the magnitude. And this, the magnitude here, R3, 1 square, this is square, we are squaring everything, will be this magnitude square. So going further to solve this, of course, the K constant is given as 9 times 10 raised to the power 9 Newton meter square per coulomb square. So we shall be utilizing this. So to find F3, okay, the force on this charge F3 due to the charge Q1, okay, so we have, this is the charge, the force on charge Q3 due to the what? Effect of the charge Q1. So we have, utilizing this formula, we have this as 9 times 10 raised to the power, this is 10 raised to the power 9 for K, times Q3. Q3 is given as 4. So 4 microcoulomb. So 4 times 10 raised to the power minus 6 times Q1. Q1 is this 6 times 10 raised to the power minus 6. All right, upon the magnitude of this square will be, so to get the magnitude of this square, so we shall have something like this. Let me clean this since we have taken note of this. So if you're enjoying this video, do well to give it a like and subscribe for more updates. So we want to find this magnitude. We want to find this magnitude. R3 minus what? R1. So R3 minus R1 gives us what's the magnitude, the distance between charge Q3 and charge what? Q1. So we have it as this now, that R31, okay, will be a magnitude of 0.8, okay, plus 0.6. Of course, this, if we take this as the vector, this will be 0.8 j plus 0.6 I, so the magnitude. So we are interested in this, so we won't consider the direction in this case. So this will give us square root of 0.8 square plus 0.6 square, and this gives us what? 1. So having found this the distance, okay, the distance between charge Q3 and Q1 as 1, we can say 1 square. 1 square. This is what? 1 square. And if that is the case, to find this now, this is the vector. This is the vector. The vector is R3, and R3 is 0.8j. So we can have 0.8j minus R1. What is the R1? R1 will be this. R1 will be this. And of course, we're having minus here. So it will be plus. So plus 0.6 I. Once we do this math, we now have that the force on charge Q3 due to Q1 will be, once you resolve this, you have it as 0.13 I plus 0.17 J. So let us find now the force on charge Q3 due to Q2 before we find the net force. So similarly, following the process we have before, we have that the force on 3 due to 2 will now be 9 times 10 to the power 9 times 4 times 10 to the power minus 6 times minus 6 times 10 to the power minus 6 times, this will be 0.8j minus 0.6 I. The magnitude here will be 1 square. This will be what? 1. Once we do this, we have 0.13 I minus 0.173j. So you can pause this and go back to how we found F31 and see if you can get the same thing. So this is the force on the charge Q3 due to charge Q2. So we have this. So what will now be the net force? The net force will now be net force, which is F31 plus F32. It will now be, this is a 0 point, okay, this will be 0.13 I plus 0.17j, this plus 0.13 I minus 0.173j. Of course, this is one. If we decide to put it in 2 decimal places, this will be 0.17j. You see that this cancels what? Out. Okay, so the vertical component of the this vertical component cancels out. The vertical component cancels out, and we have 0.13 I plus 0.13 I. And if you sum this, you have, so if you sum this, you have 0.26 I. Now you see that the vertical component of the force cancels out and the horizontal component adds up. Okay, so you now see that this net force is parallel to the x-axis. The net force is parallel to the x-axis. So you shall use this this example that I've solved to solve this one. So if you have actually enjoyed this video, do well to give it a like, share it with other students, and subscribe for more updates like this. Thank you for listening.